or introduce advantage function. Let's first briefly introduce how the reinforcement learning method is used to find the optimal policy. In reinforcement learning, we first define this expected Q value function through this cumulative reward. And we'll define another expected state value function through this Q and the policy pi. Then we use the dynamic programming to solve this Bellman equation, find the Q value. From this Q value, we can find the optimal Q. And then we first find the optimal policy. Finally, we can find the optimal state value function from this equation. The idea is an agent at its current state and takes action A. It moves to this point, not to next state, because without this environment information, it doesn't know where to go. So at this point, by exploring the environment step by step, we got the return, cumulative return. From the return, he check this Q value is maximum or not. If maximum, then that's A is the optimal action. So then we find this Q value, this V value. So right now, agent at this point, what we want to do, we want to change the angle of the view. That means your agent stands at current state to see what's the relation between this state value function and the actions. In many applications like here, self-driving, at this state. So we should do something or not. Here, if when a car in front of my car, should I do something or not? To answer this question, we need to define an advantage function. Advantage function simply defined as the difference between this Q value and the state value function. That means we just separate this action from the Q value. And then we, this advantage function satisfied with this this equation, because we take we calculate the expectation of Q and V 0. So this they are equal. So this is 0. This is in the expectation formulation. If in the sample formulation, we can write the define the A as a simple, it's a Q minus V. What does that mean? For example, in the double deep Q network, we have two networks. One is a Q network here. Another is a target network. This this is regular convolutional module, and here is the output. We keep the same as the double deep network. In Q network, we insert two modules. One we add here, we output the Q value for this input state S. And another one is output the state advantage function. That means this advantage function over the possible actions. And then once we have this V and we have this action distribution, so we can find the relation between the state value function and the actions. That means, at this state, at state S for this value, should we do something or not? Depend on this A value. And also for a given state value function, we can see which one is a match to this state value function. Or we can find which action will generate the optimal state value function. So we have once we have these two modules, we can find the relation between the city value function and the actions. That's the idea. Rest of them, we use the same idea, generate. We will use the target network generator target and use this target to train this Q network in a supervised manner. It's the same thing. The idea of the advantage function is just change the angle of point. I mean, it's not from here. We stand here. We separate the action from Q, and then we can find the state value function, the relation between state value function and the actions. That's the idea. If you need further information, please check with this reference. Thank you. Bye.